Aloha and welcome to the video on fronts. In this video we will go over the formation of a front. We'll differentiate amongst warm fronts, cold fronts, stationary fronts, and occluded fronts. We'll describe the formation of a mid-latitude cyclone, and we'll describe how airflow in the atmosphere fuels cyclonic and anticyclonic circulation. So before we get started on types of fronts, we should probably discuss what a front is. A front is where we have two air masses and they're going to collide. In this case, we have the formation of a warm front, and a front is named for the type of air that is moving. So in a warm front, we're going to have a cold air mass. We'll just put that here. And it's going to be colliding with a warm air mass. And in fact, the warm air mass is going to be moving towards the cold air mass. And that's where we get this little interaction point right here. And this is where our front is. So if we take a look at the front, we can see over here that we have this warm air mass that's going to be moving in this direction into an area that is populated with this cold air here. So warm air, being less dense, is going to be forced up and over this cold air mass. And what we see is the formation of stratus clouds. So we're going to have some cirrus clouds that are going to be way out here in the far, and that's our clue that we have a warm front coming. We'll see some cirrostratus and altostratus clouds, and then right there at the front level is where we see this nimbostratus cloud formation here. And what you're going to get is some prolonged rains that are coming, like a long day's drizzle. It's not going to be a big storm, but you'll have that rain that's coming. Once you have this front pass, then you are in cold air. As the front moves over you, you'll notice that the air temperatures are going to be warmer afterwards. So a warm front, you can see it coming by looking at the clouds. You'll see a building up of the sky with clouds, first the cirrus, then the stratus, ultimately a nimbostratus, a gray sky with some drizzle, and then from there we'll get the warmer temperatures afterwards. Now in this slide we have a cold front, and remember we said it was named for the air mass that's moving. So here we have a region where we have some warm air that's settled in, and then we're going to have a cold front move through, or a cold air mass move into the area here. And it's right here is where we see this front formation. Now, a cold front's kind of like a bulldozer. So what we're going to have is we're going to have this cold, dense air here that's bulldozing its way into this warm air. So instead of having a nice gentle buildup of clouds, instead what we have is this cold front come through, and it's going to cause this warm air to really quickly rise up. And when we have that rising up, we're going to develop this cumulonimbus cloud, which is a thunderstorm. So we'll experience severe storms at a cold front. Now if you were over here and you felt this, or you had this experience of this cold front coming through, what would happen is you would have nice warm days, and then all of a sudden you'd look and see these thunderstorms coming. One of the interesting things is if you look at the top of the thunderstorm, it kind of gets blown in the direction that it's going. So they call it an anvil cloud because it looks like an anvil, but it actually will point in the direction that it's going to be traveling. So you could see this coming. You'd experience some heavy, severe rains coming down. They're relatively short in duration, and then afterwards you'd be in this colder air. So you'll notice a definite cooling of the temperatures afterwards. And this is a cold front and how it forms and goes through. Now here we see the pictures of the formation for an occluded front. And an occluded front is kind of an interesting front if we look at it. What we have is we have a cold air mass that's kind of settled in here. And there's a warm air mass that's taking over here. It's kind of coming in this way. It's moving along relatively slow, but we have that warm front going. And then behind that, we have another cold air mass coming through, which is going to be traveling a little bit faster. So we have, in this picture, we notice we're going to have a warm front here, and then we'll have a cold front here. So this is how we set it up. And when we look in the picture, you can see we have our warm front here. Remember, a warm front means we have cold air. Warm air is on the move. And as it comes there, we get to see our cirrus clouds and our stratus build up. And finally, we get to our nimbostratus rains down here. So it's going to be kind of cool here. You'll experience a day-long rain, kind of nice and slow movement there. And then we have the warm air. Behind this warm air, we have this cold air that's moving also. And it's going to be moving a little bit faster than the warmer mass is going. So we have a cold front here. Now this cold front is going to be symbolized by our cumulonimbus storm clouds here, our thunderstorms, and our big storms on the end of this. And what we notice as we go down through the pictures is we're going to get to an occluded front here. And an occluded front is where we have a cold air mass that's going to join up with another cold air mass, and it's going to lift up a warm air mass in between them. So as we look at it, initially we're going to have a cold air mass here, a warm air mass here, and then we'll have another cold air mass coming here. And this cold air mass in the back is going to be traveling the fastest. So in the next picture, in picture number 2 here, what we're seeing is we still have that first cold air mass, but now we have the second cold air mass is joined up with it, and our warm air is now going to be lifted up to here. And we can see some storm and rains going on that way as well. So this is how we have an occluded front, and we can see that one right here. Okay, and what we're talking about is basically we have cold air, warm front coming through, and there's a cold front that's traveling behind it a little bit faster, and it'll eventually scoot that warm air up and out. Okay, in this picture there's a bunch of different things. It's a little bit of a summary for us. We'll start off with our cold front. Remember, we have warm air on this side, cold air on this side. The cold air is moving in this direction, and we're going to see these thunderstorms, these cumulonimbus clouds forming. On a weather map, you'll see a cold front, and it's going to be represented here by our blue triangles. Now, blue is going to be cold, triangles kind of sharp, so this is where we have severe weather for the most part, and the arrows are going to point in the direction that that front is moving. So if you look on a weather map and you see these blue arrows moving, pointing in a direction, that's where the cold front is going to be moving towards. Now in this picture we have a warm front, so we have cold air that's in, and we have warm air on the move. And remember, as warm air goes, it's going to kind of slide up here, and we're going to get our cirrus clouds, our stratus clouds, and finally our nimbostratus, light drizzly rain clouds here. And a warm front is going to be a lot gentler. So what we'll notice is our symbol for a warm front is going to be a curved half moons like this, and then they're going to point in the direction that the front is going to travel. So our cold front's going to head up the page, our warm front would also head up the page, as this example is. Then we have our occluded front. Remember, the occluded front is we had a cold air mass, there was a warm front coming in, and then we had another cold air mass that was moving closer, and it kind of comes together and they push that warm air up and out of the way. So an occluded front's going to move. It'll look like this. We generally will use both symbols, and sometimes when you look at a weather map, the occluded front will be in purple. They'll kind of purple it out, and we can see that in a later slide. And then there's this last front that we didn't spend a lot of time talking with, and this is quite simply a stationary front. And a stationary front is exactly like it seems. We have a warm air mass moving one way, we have a cold air mass moving the other way. They're kind of bumping into each other, moving back and forth a little bit. There's not a lot of motion, so that's why we call it a stationary front. And for the most part, it's going to be warm and cold. It's really kind of neat if you find one. You can drive from the warm side to the cold side, and you can actually feel the temperature change. So stationary fronts don't really move much. We don't see an awful lot of weather with them. One of the things, though, I do want you to know is if you notice here, in the warm front we saw weather, in the cold front we saw weather, the occluded front we saw weather, and even the stationary we see a little bit. Most of the times when we see weather, it's going to be in these front situations where these air masses are colliding with each other. Okay, so this series of pictures is kind of show us how we develop these low pressure cyclone systems. So what we'll notice is we have situation number 1 over here, and that's going to be situation 1 here, and we're going to kind of move this way as we go down on our track of time this way. So initially we're going to see this stationary front, which we see right here, and it's going to be here. Remember, that's where we have a cold front and a warm front. They're kind of moving side to side. They're not really moving back and forth an awful lot. Now, over time, we're going to see the warm air is going to start moving a little bit. Remember, we have the Coriolis effect. It's going to bend a little bit. We're going to start seeing a little indentation here from the warm air. The cold air is pushing up. It's going to start to bend this line a little bit. And what we'll see is we see that over here in situation number 2, where we're seeing that little bend. Now, as time goes, this bend gets a little more pronounced. And now what we have is we have this warm air moving, which is now going to turn into a warm front. And we see that by the red air half moons facing this way, and it's going to be moving in this direction. But we also see a cold front forming over here, encroaching in on the warm, and that one's going to go in the direction that we see the arrows form. So if we look at our picture here, what we see now is we see a warm front moving this way and a cold front behind it moving this way. And that's going to give us this kind of circular nature that we call our cyclonic systems. As we go a little bit further, we have this cold air catching up and we get this occluded front here. And you can see that it's purple in this example, with our still warm front here and our cool front over here. So we can see how the storm is going to continue to build and it's going to continue to go. And then ultimately we get into this huge system over here. We still have our low. Notice that the winds are going to circle around this way. We have this rotational form here. We still have our severe weather coming here on the cold front. We have our warm front here. Everything's kind of breaking up. And then ultimately it blows itself out. It'll kind of mix up, and then we have the dissipation of the storm system here. So this is how we form these mid-latitude cyclonic lows. Is you'll see how we start off. We'll have this low pressure going. It'll slowly start off with a stationary front, and then we'll start to form these other fronts, and you can see how it's going to spin around a little bit. Now, when we have cyclones and anticyclones, or high and low pressure systems, you can see how this is going to move our fronts around. Okay, most low areas are going to pull the air inside of them. So it creates this little vacuumy kind of system here. That wind's going to move upwards in a cyclonic fashion, and then it's going to kind of dissipate its way out. So this is how we have our low pressure systems here. Our high pressures are this opposite. We're going to be taking some air in. It's going to kind of cyclonic way down, and then it's going to dissipate when it gets down onto the ground. So we always are going to have our wind going from our highs to our low pressure systems, and that's what's going to drive these fronts going along. So when we have these highs and lows, in between them is where we're going to see this weather formation that we're used to. So we can see our cold fronts and our warm fronts in between the two, because that's where the wind's going to be blowing these air masses and causing them to interact with each other. Okay, so that's it for our video. As always, good luck on your quiz, and we'll see you in the next video.